All right, so officially, welcome to another session of our PLD discussions. And in today's session, we are looking at two major things, pointers and arrays. And the scope of today's lesson is for us to understand what pointers and arrays are. Then during tomorrow's PLD, we'll look at how practically we are going to be using them or how we use them in real world programs. Okay, so today it's more about getting the understanding of what pointers are, what arrays are, when to use pointers, when to use arrays, and why are they important. Okay, because if you get to understand why these are important, then you using them becomes very easy. So let me get onto the board so that we begin. For those who are new here, note that it is a discussion. In as much as I'm going to be doing most of the talking, it's still a discussion. So along the line, you can pause me anytime and ask your questions if you need any clarification. And if you also want to make a suggestion or add on to whatever is being taught here, you are allowed. Okay, that is why it is a peer learning discussion, so that we all can share our views and learn from each other. So on that note, we are starting with pointers. And okay, pointers. Hopefully by now we've all seen what pointers are, but what are they really, and why at all do we even need to learn about pointers? That is what I want to bring to the fore right now. What are pointers and why at all do we need pointers? So to understand pointers, we have to understand the concept of memory and storage in our computers. Okay, so not only your computer, but almost every electronic gadget that uses some form of memory would also have these things. What am I talking about? So when we take any device, for now, let's just stick to a computer. So when we take a computer, the computer has what we call the RAM in it, or the random access memory. And this memory inside the computer is where various processes take place. Okay, so when your computer is processing stuff, currently as we are hosting this session, my computer is working because I'm running an application on my computer. I'm currently running Telegram on my computer. So when you go into the memory of my computer, there are a lot of processes that are going on or happening in the memory of my computer. And all that the memory does is to provide some form of storage for these processes. Okay, so as soon as something starts, this memory or the computer will automatically allocate a particular location on the memory for the purposes of storing it. In the same vein, when we begin to run our program in C, okay, when you run your program in C, there are these things that you do, assigning of variables or creation of variables, creation of functions, all of those things, they do not happen in thin air. Okay, when you create a variable, you yourself, when you go and create a variable, let's say variable x is equal to 5. If you do this on your computer, you the programmer, all you see is that, oh, I've created a variable. And anytime you call x, it's able to give you 5. Anywhere at all you call x, it's able to give you the value that you assigned to it initially. So the actual question is, where is this 5 being stored? How is it that I can come and use this? Okay, so behind the scene, inside the computer itself, what is happening? That's what we want to understand. On the surface, all we know is that, oh, I created a variable called s, and I assigned a value to it, 5. Good, that has been done. But you just wrote it. Assuming I write something on a sheet of paper, if I write x is equal to 5 on a sheet of paper right now, all right, if I put the paper away, there's no way I'm going to get x is equal to 5 somewhere else unless I state it again. But the computer, it doesn't work that way. You initialize it by saying, oh, x is equal to 5. And when you move on, deep down in your program, you still can call s. Say you can decide to print s. And when you print x, it's still going to give you 5, meaning there is some form of storage. Something is storing what you have already initialized. And what is happening is that the memory, in our case, the RAM in our computer, is able to create some specific location on it to store the variable that we declared. So inside some part of the memory, there is a part that has been stored where x is equal to 5. So anytime we decide to call x, our computer knows exactly where it stored x when we initialized it. So all you did initially was to say x is equal to 5. That process is what we call initializing a variable. Well, you've already initialized a variable. Or even when you just declare a variable, say int x, after declaring it, automatically our computer creates some space within its memory and allocates that space to x. Then anytime you want to reuse it, the computer knows exactly where x is, so that it will go directly there to pick it. But how does the computer get to know exactly where it stored x? So imagine when you assign, let's say, 3 different variables. Y is equal to 7 and z is equal to 10. Assuming we have assigned all these 3 variables, our computer will automatically, wait, please, if you are not speaking, if you unmute yourself, I presume you want to speak, okay? So if you unmute yourself, then you have to come to the floor. Otherwise, kindly let's remain muted so that we don't distract others. All right, thank you. So we have initialized 3 variables here. And what is going to happen is that each of these variables are going to be stored inside somewhere in the memory. So that is done automatically, okay? So we do not determine where to keep what. The computer will automatically assign them to specific locations. So say here is z is equal to 10 is stored here, then y is equal to 7 is stored here. These things have been stored inside the memory, but anytime we need to use it, our computer is able to go directly into this memory spot and bring them. So how does it do that? How does the computer even know? And how does it even remember that for x, I kept x in this location, and for y, I kept y in that location? It does that by keeping record of their addresses. So each location on the computer's memory is assigned an address. The same way each of us right now has an address for our location. So if you should give me your address, that is the longitude and the latitude of where you are right now, I can locate you with that. So as humans as we are, wherever we find ourselves, there is an address to our location. And this is how we get the address. The longitude and the latitude will give us the address. In the same way, when anything is stored on the computer's memory, it is assigned automatically, it is assigned an address. And this address happens to be in the form of hexadecimals. The address that is assigned to all the things that are going on in the memory of the computer are assigned addresses in the form of hexadecimals. So this is like saying, when I want your longitude or your latitude, please, if you are not speaking, don't unmute yourself, please. If this is just like saying, okay, your longitude and your latitude are given in a particular order, obviously. If you don't know your location, your current location, you can pick your phone right now and check, just Google my current location, and you will definitely find it. I wish I could quickly do that. Current location. At least Google will be able to pick your location. Yes, so it's been able to pick my current location right now and your GPS address. Okay, so that can easily be gotten. That is how our world has been made to be, or the globe has been made right now with the help of GPS. So in the same way, in the computer, anything that is stored inside the computer is able to automatically assign a location to it. But this location comes in the form of hexadecimal. So they are the addresses. So if I ask you, where did your computer store the variable you created? It stored it in a specific address. So what is that address? The address will be in the form of something like 0x8A7B98896, something like this. So that is the address. So if you give your computer this address, your computer knows exactly where this is. Like, it knows the exact point and it knows what it has stored there. We are getting to pointers, but we need to understand why they are even in the picture in the first place. Why are they in the picture? So before we understand why they are in the picture, we need to understand how the memory of our computers operates. And all that I've said in summary is that the memory of your computer is such that anything that happens inside your computer, especially when it is processing, is assigned a location on the memory. Various parts of your computer will come together to do things. They will come together to do process things for you. But at any point in time, they need specific data, specific information. They have to go to the memory, the RAM of your computer, to go and gather or get the specific information they are looking for. So you wrote a program, and that program uses a variable. The variable is called X, and you assign a value 5 to the variable X. Anytime your computer needs to use that variable, it knows specifically where the variable is stored because of the address that it has. Okay, so now, how then do we get access to the address? That is where pointers come in. So pointers is that, okay, so let me say this before I even talk about pointers. Why do you even declare a variable? Why do you declare a variable? Because you could have given your computer just the number itself, 5, and you know that your computer is going to store this 5 somewhere. And after storing the 5, it's going to associate the 5 with the location, so the address of that digit or value it has stored. So all you, the human being, would need to access this, or you, the programmer, all you need to access this is the address. But you and I know that this address is very unfriendly, because how will you be keeping something like this in your head? How will you be keeping something like this in your head? And imagine if you have to declare about 12 variables or 120 variables or 2,200 variables in your application. Are you going to be able to keep the address of each of them? That is near to impossible. So what programmers decide to do is that, okay, instead of remembering the address, why not create something? In the first place, why not create something that we can easily remember? So we decided to create what we call variables. So instead of trying to remember this address and the value, all that I care about is assign that value to X, so that anytime I need it, I don't care about the address. I'll only go for the variable, because I can easily remember this. So when I pick this variable, then anytime I have access to the value. Okay, but in C programming in particular, or some other close relatives to C language, we will sometimes need to have access to the specific location. So if we don't need a location, we wouldn't bother ourselves with pointers. If it is just the value that we need, we can just stick to our variables. But in C, we are going to be talking about it soon, why we need pointers. There are some times that we will need specifically to use the address. So to help us remember these addresses, because these are weird values that we can't just memorize. So to help us remember these addresses, we come up with specialized variables called pointers. So you remember what I said. The variables are just to help us call the values anytime we want them. And we don't have to remember their addresses. We don't have to remember. We don't care about where they are stored. All we care about is the value that was assigned to them. But there are special situations where we need to know exactly where they were stored so that we can go and make some modification to them. In those instances, we need to remember the address, which is unfortunately not easy for us to remember. For that matter, we are going to create pointers. So I said that pointers are just special variables. Special variables. Why do we say they are special variables? They are special variables because unlike the ordinary variables that we use, they do not just store values, but rather they store addresses to the value. That's the only reason why they are special. So it's just like calling any variable at all, but instead of assigning a value to the variable, this time around you are assigning an address. So practically, what does this mean? Yes, last 2 days during the session, when I was trying to explain this, I used an analogy of using a hotel. Okay, so what we had is this big hotel representing your memory. Okay, that's a very big hotel. And in the hotel, there are several rooms, several of them. Okay, so the rooms are all over the place. If somebody decides to book a room in this hotel, the receptionist automatically assigns you to the room based on how much you are paying. Okay, so in the same way, our memory will automatically assign you to specific spaces in the memory, depending on your size and how much space you are going to occupy. It's the same scenario. So this is our hotel, and the receptionist is going to look at, are you looking for a family room? How many people are you coming with? Are you alone? How big? What are your requirements? So in the same vein, your computer is also going to assess the things that you want to store in it. What's the size? What's its requirements? Will it fit here? Will it not fit here? Then it will automatically assign you to a specific room. So in the same hotel analogy, each room in the hotel is given a room number. Each room in the hotel is given a room number. So we can say that each room in the hotel has an address. And if I give you that specific address, you can locate that room. Okay, so in the same way, our computer's specific location inside the memory is also having an address. Just as any guest to the hotel will be given a specific location, anything at all that is to be stored in the computer's memory will also be assigned a specific location. So let's assume that this is room 106 and this is room 109. If we decide that we are going to put our variable x in room 106, so in our hotel analogy, we will say that, okay, so there are about a family decided to come and stay, and we assign them to room 106. This room 106 seems easy to remember. 106, you can easily remember it. But now let's assume that the room numbers were not in this format. But room 106 is actually 10687BC F G. Let me just say this. Let's assume this is the room number. it becomes quite difficult for us to remember this room number. So if we want to keep this room number in memory, what can we do? Maybe this 109 here, we can decide to write this room number on a sheet of paper, a big paper, and put it inside this room. So that anytime we are looking specifically for this, all we need is come here, look at the address. You will find that room that you are looking for, the room number. So what this room is doing, when I go there, is just a big sheet of paper that has this address on it. So it is rather pointing me in the direction of this room. So this room 109 becomes a pointer. Just as the name suggests, it just points you in a specific direction. So it's just like you going to look for somebody, you don't know the specific place, and you meet somebody along the way and you say, hey, please, I'm looking for this person. Okay, I'm looking for this person. And he shows you, okay, this, go down the street, go to, take the junction to your left, turn right, and to your right, you'll find this building, enter the building. So what is this person doing? Is pointing you in the direction of who you are looking for. So that is what pointers do. They just keep the address of something else in the location of the memory, because the address is not easy for us humans to memorize. So instead of memorizing the address, we'll just create a special. So this is what is happening here. Let's use our variable x for the explanation. X is equal to 5. We know that. So this time, anytime we want to use 5, we'll just call x. Great. But we want to also have access to where 5 is stored, because sometimes we want to manipulate it from its storage. How do we get that? We will need its address. But this address is a weird value that we can't remember easily. So for that matter, let's say this is the address, or an A here. Let's say this is the address, and we can't easily remember this. So what do? We decide to create another variable called P and assign it to this. So that anytime I want you to call the address, you don't need to go and call this. Just say P, and P contains the address. That is all we are doing. So for each variable, for each function, for each array, almost everything that you are going to do with your program, it has an address. So the variables you create has addresses, the arrays you create has addresses, the functions you create, all of them will be assigned unique addresses. And anytime you need any of the address, because you can't easily remember them, what you can do is create a new variable and assign it to the specific address, so that if you need the address, you would just go for the variable you have created. And that type of variable that just stores addresses are called pointers. So now I've tried to explain pointers. Any questions? Let me pause here and pick your questions. Any questions on what pointers are, or any clarifications, additions, subtractions, anything at all? Yes. To our newcomers, you are always allowed to talk. Don't worry about being new here. It's a forum for all of us to learn. So you can just unmute yourself and talk if you need to. Yes.
Good day, Dr. Obed. Dr.
I'm
Obed, I hear
listening.
you.
Yes.
All right.
Okay, so yes.
Yeah.
Continue.
About I like how you went about these pointers. Thank you very much. You broke it down.
Thank you
Um,
too.
yeah, I was thinking how there are various ways these pointers is being expressed. You know,
Okay.
declaration, initialization, and
Okay.
the way the way it's being put into mathematical statements. There are
Okay.
cases where you just have to write like you did here now. You just put P equals to the address. In some cases,
Yeah.
they are actually putting asterisk P equals to a value
Yeah.
or an address. So, and then in some cases, they are using and they're combining it in an array format where they are adding p plus one. They are talking of
Okay.
pointers p plus one, or the
Okay.
arrays increasing plus one or plus two.
Okay.
How do we get to assimilate these ideas and
Okay.
understand exactly what is going on there?
All right.
Thank you.
All right. Welcome. All right. So just a quick response before any other person comes up. So what's happening is that all that I've done right now is just to explain what pointers are. And that is what I need you to get right now to understand what they are. We'll then move on to all the other aspects, the declaration, the initialization, how to use it. So, in fact, in today's session, our interest is getting to understand what they are. Tomorrow's session, we'll get more practical and do work with pointers and arrays as well. But all we care about right now is for you to understand pointers. Because even if you don't understand it and we just get into the practical, that is when you get confused. At some points that you don't know why this is happening, you don't know why they added this, you don't know why they wrote this in this way. Okay, so for now, let's just focus on understanding it. I get your point, and we are definitely going to get there. Okay, so we are going to look at all those aspects. All right, next
Uh,
person.
okay, good morning, Mr. Obed.
Good morning.
Um, if I may get it clear,
Okay.
pointers are just address, right?
So they just contain address. So variables that contain address.
Of another variable.
Yes, exactly.
Okay, thank you.
So what you should also remember is anytime we say a variable, we are referring to a container. Okay. Anytime we say a variable, that's those of you who are new here might not have seen our previous PLD sessions, but we did. I think the very first PLD session we published, we talked about variables. So the link is available. I think it's on YouTube, so you can always have access to it. But all you need to know is that when we say a variable, it's actually a container. What it contains is totally up to you. So in C, we always talk about data types. So whether an integer, a character, a float, a double, whatever you decide to put in, all you should know is that a variable is just a container. So it's a container like any other container. It could be this. Okay. So this is a variable. Let's assume anytime you hear a variable, it's just a container. You decide what to put in there. So you have decided that you are going to put this value 5 in that container. Okay, so let's assume the cap, there's a cap, and I've decided to put 5 in there. That is all when we talk about variables, is a container. But this time around, we have a special container. And this special container doesn't pick just any values at all, but it rather picks addresses. Okay? It just keeps addresses. So it's still a variable, but instead of picking values like any other variable, they contain what? Addresses. That is all. But when we say an address, definitely an address is a location to somewhere, something. Okay, so it means that if this contains an address, the next question is whose address is this? Whose address is this pointer containing, or this special variable, whose address is it containing? So we'll try to find the specific address. Where is this address pointing to? Then we'll realize that, oh, this address is actually pointing to another variable somewhere or another container somewhere. So that is the role of the pointer. So this container here is what we refer to as a pointer. It contains the address, that points to something else.
Okay.
So it could point to almost anything at all that has been stored in the memory of our computer.
All right.
All we care about is that this container should contain an address. And we know that this address is an address of something else in memory of our computer. Whether it is a variable, it's an array, it's a function. The pointer is telling us that, oh, when you go to this address, there is something there. And we are going to get there soon. When we start declaring pointers, we are going to tell it the type of data that is going to point to, whether it should point to an integer or a character. But all we care about when we want to understand pointers is that the pointer is just a container that contains an address. So you go and look at that address and follow your map. Okay, this address goes to this person's house. Okay, so let me follow it. Google Maps, show me. I've given you the address. Then I'll follow it and come and find you in your house. Then when I get there, I know that, okay, it is this person who is actually here. So assuming that right now, randomly, one of you decides to give me your home address, and I don't know exactly who is there. You decide to give me your address, and I follow this address. What's going to happen is eventually I'm going to get to this location and I'll find exactly who is in that address or who is in that location that I was given the address of. So all that the address did was to point me in your location. That is all. So that is all pointers are doing. They are just containing addresses that point you in the direction of a specific thing. When you go there, that is when you know what it is. Whether it is a value or a normal variable, whether it's a function, it's an array. But all we care is that a pointer should contain an address. Yes.
Yeah. So far, you have been stressing so much on pointers, and I think the topic, or let's say what we are dealing with at this week, has been more of pointers, arrays, strings. Did you also talk? I didn't start from beginning, so I want to know: have you talked about arrays and strings and their
No,
relationship with the pointers, or you are
not yet.
getting here? All right.
Not yet. Yes. So we are now moving. We want to tackle today. Our focus is on pointers and arrays, trying to understand them, why we need them, when to use them. Okay, that's the most basic things. If you don't understand those ones, it becomes challenging working on the projects that we've been given. So we are trying to focus on understanding them, grasp the understanding, then we can move on. Okay. So to me, understanding these basic concepts is the most important part. We may see that, oh, we have a lot of tasks that we are yet to do or all of that. But without a basic understanding, you can just quickly run through the tasks. And I bet you next tomorrow when you are given another problem, you're still going to struggle the same way you struggled right now. So you need to get your foundation solidified. And that's exactly what we are trying to do here. So make sure everyone understands what pointers are. Once the understanding is clear, then we can move on. Any other questions? Any other questions?
Yes, please.
Okay.
Yeah. Do you mind? I don't know which like a compiler or application that you're working with, but it wouldn't it be? I think it would be ideal if we start trying out expressions with these pointers using applications, to describe more how the it works, and then at least so that we too can be also of how we can use it. That's just a suggestion.
Yeah, so that is noted, and we actually do that. But today's lesson is not on the practical application of this. So tomorrow's session, that's where we are going to do that. We do all our practices. In fact, we even have sessions where we all get to practice on the same compiler so that we can all code and see the outcome. Okay. But for today, as I keep saying, our interest is in helping you understand the concept. In fact, this is actually a repeat of our last 2 days session. We are just trying to get the understanding so that tomorrow when we begin doing the practical session, it's not now that we are going back to answer the question, oh, I don't understand this thing. Why at all are we even using this? Okay, so for now, let's just slow down, try and understand. Once you understand it, it's not even about the application right now, it's about the concept. If I say a pointer, do you understand it? Okay, that is all we are trying to achieve now. Tomorrow we'll do the practical, so don't worry, we'll do it live here for you to see, God willing, tomorrow. Any other questions? Otherwise, let's talk about why pointers. Why pointers? So if I could use a variable to represent my value and always get access to it, why at all do I need pointers? Why at all do I need pointers? Sorry. If I can assign a variable to my value, why do I need pointers? So it may interest you to know that in some of the higher languages, there is nothing like pointers. Okay, so when we go forward in the program, when we leave C and go to other languages, you realize that we don't use pointers in there. But C can be considered sort of a middle language, closer to more of the machine language than the other languages we will be dealing with. So according to C, there are certain things that we can't do with the variables. So even though you can assign variables to your values, there are certain points in your programming that variables do not become practical. One of such points where you strictly need to do work with pointers is what we call memory allocation. Memory allocation. So one advantage of programming in C is that it helps you to manage your memory very well. That is why I started by talking about how the computer's memory works and how it's able to automatically assign spaces within that memory for the various things that we declare. Okay, so when we come to memory allocation, which is actually a topic that we are going to learn later in our course, we are going to learn that later in the course. We are going to be working directly with pointers. So for now, all that we are doing, we are trying to understand pointers, where to use them. But when we get to memory allocation, that's specifically what we are going to be doing. So we can't use ordinary variables when we are working with memory allocations. The other more important reason why we need to be using pointers is when we are working with some functions, which the tags that we did yesterday would have pointed you in that direction. What do I mean by this? Ordinarily, when you are using a function, you are going to pass some arguments to it. Okay, so let's say argument x and y, which are all integers. If you happen to have declared, let's say, the variable x here already, let's assume you declared the variable x here already, and this your function is going to make use of that variable and operate on it. Assuming within this function, what is going to happen is that you are adding a value to x within the body of this function. What happens is that if this your x was equal to 5 initially, inside this function, you would have 5 plus plus, meaning now we have added 1 to 5. So x has become equal to 6 within this function. Unfortunately, when we go back to the specific location where this variable was stored, even though our function has manipulated the x and gotten it to be 6, when you go back to the location, it will still be x is equal to 5. So the question is why? The reason is that in C, functions just create their own copy of what you have. They don't use the actual thing. They create a copy. So it's like a duplicate that it has created and is using. So you don't get to modify what is actually stored inside the memory of your computer. That is there. So the problem is, what if I wanted to actually change that value that I stored initially? I want to update that value I stored initially. What do I do? If you want to change that value you stored initially, then what you have to do is that instead of just giving us the value where the function is going to create its own copy and use, this time around, go ahead and pass the address. Because if your function knows a specific location, it will go to that location instead and go and change it. So anytime you want to specifically change the value that you stored, you have to pass the address. And you and I know that from our previous discussion, we can't keep the address in our memory. As in we, the programmers, can't keep record of the address. For that matter, we assign a special variable to it called a pointer. So all we'll have to do is, instead of passing a variable to it, we'll pass a pointer to it. So it will be a pointer rather, and not a normal variable. So these two specific situations are when we really need to use pointers. The first is when we are doing memory allocation. The second is when we want our function to work and make changes to the variables that we have declared already. Like we want to update the values in the memory. Then we need to use pointers. Very important. Memory allocation and when we are working with functions. So that is how come, let's say yesterday's task, one of them, we're talking about joining two strings and we're passing pointers to the function. The reason why we're doing that was that we wanted to effect the changes to the storage, whatever was stored. So if string 1 was stored to be, let's say, hello, as we had in our example, if I just pass the normal string to the function without passing, if I pass just a string as a variable to function, it's going to operate on it fine and return whatever I want it to return. But when I go into my memory, I'll still have string is equal to hello. So if I want to effect some changes to what I have stored inside the memory, then I need to grasp the location of the string or the address. And I do that with the help of a pointer. Okay? With a pointer, any changes that I make to this string will immediately be effected inside a specific location that it found itself. Okay, so that brings us to how to declare a pointer. How do we declare a pointer? One thing, when I mention declaring, one thing that I want you to pay attention to is that in C, almost everything that you are going to do, you are going to declare something. So in our previous sessions, we talked about how to declare variables. We talked about how to declare functions. And now we are talking about how to declare pointers. Very important. And anytime you are declaring something in C, you need to tell us the data type of interest. The common data types that we keep using are integers, floats, characters, and doubles. At least those are the common ones that we use. Okay, so anything at all, anytime you are going to make a declaration in C, you are going to tell us whether we are going to be working with integers, floats, characters, doubles. And never forget that the pointer is a specialized variable. For that matter, the pointer is just a container that contains an address, and the address points to something. So what data type does this address point to? That is the question we need to answer before we can declare a pointer. Your pointer is just a container that contains an address. This address that it contains points to something else or a different container. So what type of data is contained in the other container that your pointer is pointing to? So if we had variable x inside this other container that our pointer p is pointing to, then we know that, okay, pointer p actually points to an integer. For that matter, we'll say int, then our pointer. But to differentiate a pointer from a normal variable, instead of writing just the variable name as we would have done, we preface that with an asterisk. So with the aid of the asterisk, we tell our computer that this particular variable that we have created is just going to store an address. That's what we are doing here. So this is how we declare a pointer. So by saying int asterisk p, all we have said here is that, okay, I've created a container called p. But this container, with the help of this, I'm saying this container will only store addresses. But what do I mean by it will store an address? It stores an address to something else, okay? So it's going to store an address. That address is the address of something in the memory of my computer. And if this happens to be a variable, for instance, what I'm interested in is what type of data is being stored in this container. So if this is an integer, then I say that, okay, my pointer has the data type of integer. Any questions on the declaration? So if this is rather, if I want my pointer to point to a container that contains a character, say H. Say this container contains H. I want a pointer Y to point to it. Y is the variable that I want to point to this. So that means that I want Y to save the address of this. Okay. All that I have to do is tell it the data type, which is a character. Then say that, oh, you need to be storing addresses. So put the asterisk in front of it. That is how we declare a pointer. So it is actually no different from how we declare variables. I could have declared the variable y this way. But just to make sure that this variable y that I've created will just store addresses, that is where I preface the asterisk in front of it. And when it comes to using the asterisk in this declaration, C is very lenient. We can write it in several forms. So you can actually preface or use it as a suffix to the character itself, then pass your y here. It can also be in the middle like that. So it is all acceptable. But I think it's cool when you have it this way, adjacent to the name of the variable, telling it that, hey, this is going to take, it's a variable that is going to be storing only addresses. So that is the declaration. The next thing after declaring is initializing. How do we pass a value to it? So we initialize it, okay? To initialize, it's similar to how we initialize our variables. After declaring like this, let's go to a normal variable. I want to declare variable x. So I do it this way. Declare variable x. Then I can go on to assign variable x to the number 5. As simple as that. So I've done the declaration and assignment. Or in other terms, initialization. Okay. So you either assign, or if it is the first time you're assigning, we call it initializing or initialization. Now, this is for our normal variables. And we know that pointers are just specialized variables. So if we want to declare a pointer to this, rather, we'll say our pointer p. This is how we declare it. And how we initialize it. Already, we have created this. This is telling us that it is a pointer. So we can go ahead and call p. Anywhere you find p inside this your program, your computer knows already that p is a pointer because that's how you declared it. Anywhere you use X in your program here, your computer already knows that X is a variable because you declared it to be a variable. For that matter, it will treat it as a variable. So you have also here, by doing this, declared that P is a pointer. For that matter, you can go ahead and use P. But you and I know that if it is a pointer, then it has to store addresses. For that matter, instead of passing a value to it, the value has to be an address that we pass to it. So we could have assigned it to something like this. If, assuming we knew that, let's say this figure that I've written here is the address for our X variable. If we knew, then we could have written it that way, address of X. We'll just pass the address of X to our pointer P. But unfortunately, we don't know the address. It is only our computer that knows. And there is an easy way for us to get the address of anything in the memory when we are in C. All that we have to do is to preface the address of symbol, which is the ampersand sign. Once you bring this in front of something, all you're telling your program is that I need the address of it. So even though I am not aware of the address of C, if I do this, I'm getting the address of C. So instead of explicitly writing the address here, which I don't know and I can't recall, I'll just say P is equal to address of X. As simple as that. So in this case, I've initialized P to the address of X. So all P is doing here is that it has stored the address of X. And for that matter, I can use it to point me in where X is and even help me get the value of X. Any questions when it comes to declaring or initializing or assigning a value to the pointer? Any questions on that? Yes. Any questions on that? Contribution, addition, subtraction. Yes. Let's go
Hello.
on then. All right. Yeah.
Good morning.
Yes, big man. Good morning, boss.
Yeah, you just said that. Good morning. Yeah, you just said that the P, which is the pointer, can help you get the value of X. I think it was supposed to be the address of X. Can P
Okay.
also get the value of X?
Yes. So it can also help us get the value of X because now we know the address. P is containing the address. With the help of the address, we can always get what is in there. And that is the next thing we are going to be talking about. Okay, so for now, we know that our P contains an address to something. But with the help of that address, we can definitely get to what is in there. If you give me your address right now, I can find you. And when I get to you, I'll know exactly who you are. That is all that is happening. P is just containing the address. So it's just like your business card that contains your address. If you give somebody your business card, that person can locate you with your business card wherever you are. Okay, so how do we get the value if all that we have is the address? Okay, so there are instances like that where all we have is the address. In this case, like we have the pointer. How do we get the value in there? So the process of getting the value of a pointer, the value that a pointer points to. So I have a pointer P, and I want to know where it points to. What is here? To be able to get this, we have a process called dereferencing. So if we dereference the address,
Sorry.
if we dereference, yes, Smith, yeah.
Before you go ahead, must we always use P
No.
the?
No.
Okay.
You can call your pointer anything at all. In fact, people use that because we keep saying pointer, pointer. And it's because people do not easily find it easy to differentiate the normal variables from pointers. So you realize that mostly when we are talking about variables, we are using X, Y, and Z mostly. Okay, so the question is, can I use any other thing for my variable? Yes, I can decide to call this variable, instead of S, I can decide to call it Obed. I can decide to call it anything at all I want. It's the same thing as the pointer. The pointer is also a variable. You can call it anything you want, provided you have declared it to be a pointer. That is all. It's just like you went to school, there were prefects and there were normal students. We are all students, but some are prefects and some are not. So if we decide that, okay, the prefects should have some tag on them that show that they are prefects, that is all we are doing here. We are just saying that, oh, when you are declaring this, tell us that it is a prefect by showing us the tag. Okay, so the pointer is that kind of prefect thing we are referring to. The pointer has the asterisk by it when we are declaring, so that it tells us that, oh, this is a pointer. Great. Now that we know the pointer is containing an address, we can use that address to go and find exactly what is located, what is stored in that specific address, that location. So always remember that when we say address, is actually a specific location in the RAM of your computer. Okay, so somewhere, maybe here, you have the address to this. Your pointer has pointed you in this direction, but it contains something. So how do I know what it contains? That is the process that we call dereferencing. So if you dereference a pointer, you are going to uncover what is inside that location. So I've given you the address, and I've told you that go to this address, have some specialized container there that I've stored something in. So all you have to do is just go find the address, go there, open the container up, and see for yourself what is inside that container. So the process of going after that address and looking inside the container to find exactly what is in there is what we refer to as dereferencing. So the question is, how do we dereference anything in C? It's simple. Anytime you want to dereference a pointer, say P that we are using here, you just preface it with the asterisk sign. Once I write this in my program, I am dereferencing it. This means that I'm telling the computer to go into the location that this P contains. So P contains a location. It has an address, okay? This P is pointing us to an address. But the moment I preface the asterisk before the P, it's telling the computer that I'm not just interested in the address, but rather I'm interested in what is contained there, what is inside that container that I have the address to. That is all. So let me just summarize the three processes again. We talked about initializing it, and when we were initializing, we did that by telling it the data type is going to point to, then with the asterisk, then the name of our pointer. So in this case, let me change it since I keep using P for my pointer. Say the pointer is X. If I do this, I've declared that X should be a pointer. This means that S should store addresses, or it should store an address. Now, if I want to get the address that S is storing, when I call S, it should give me the address that it is storing. But in this case, I have not passed any address to it. For that matter, I would have to assign an address to it. And you know that there is an address of sign. This one, this symbol tells your C that you want address of something. So whatever you are passing to it, let's assume you have a variable called sum. So if you do address of sum, then it means you are storing the address of sum here. So you can consider this as that your notebook that you write people's address inside. So X is just a notebook. So by doing this, you are saying, hey, this notebook that I've bought called S. All I'm going to be doing with it is storing addresses in there. Then I find Mr. Sam. I get to meet Mr. Sam, and I decide that, okay, let me write Mr. Sam's address in this new notebook X that I've gotten. So I go ahead and write it, and this is how I do it, by saying X is equal to address of. So this symbol here is read as address of. So what the expression I have here, you read it as address of Sam. So I'm just writing address of Sam in this my X notebook. This means that if I go ahead and just print X, okay, if I print X is going to give me the address of this. So maybe we'll have something like this, something like that, hexadecimal value. That is what the address is. So that's what it's going to print for me if I go ahead and print X. But we've also talked about the fact that now that I know that the X has an address, it contains an address, it points me in the direction of a location or a particular container that contains something. If I'm rather interested in what this container contains, then instead of printing X, I'll rather dereference it. And I do that with the help of the asterisk before the name of the variable. So asterisk X will rather give me the value that is stored here. So let's assume Y is equal to 5 was stored here, then X, this will give me is equal to 5. When I print it, that is what is going to give me 5. So in using pointers, there are only 3 things you need to know. When you are declaring, you use the asterisk. When you want to assign an address, you use the address of symbol. And when you want to dereference, you still use asterisk. So the first asterisk that you use just tells you that, oh, you are creating a pointer. The second asterisk that you use tells you that you want the exact value of this pointer. Any questions? So we've talked about pointers. Tomorrow we'll look at how to practically use this. Any questions before we jump to arrays? Yes. We've talked about pointers, how to declare them. So we've talked about what they are. We've talked about when we need them. That I mentioned in memory allocation, which is a special topic that we will discuss later. Then we talked about some functions making use of pointers and why those functions need to make use of them. So I explained that some functions need to go and modify the exact value that you stored in the memory of your computer. And anytime you need to go and modify the exact value and not just create a copy of it, you need to pass the pointers to it so that you can go and modify the original value. Okay? Then we came to declaring functions, declaring pointers, which we say with the help of the asterisk and the data type. So you start by telling us the data type that is going to be pointing to. You pass your asterisk here, then the name of the pointer. So name of pointer. That is how you declare. Then we can also assign.
Okay.
Yes.
Yeah. Is there anything like pointer increments? Something like asterisk P plus plus. Pointer increment.
You can definitely increment it. So all that you need to know here, let's say when we talked about P, okay, initially we declared P to be a pointer. So if I use P in my program, all of us agree that P is a pointer and it contains an address. This means that anywhere at all, if I go ahead and I print P is going to give me an address, okay, an address of something. But if I dereference P, it's going to give me a value, say 5, if that was what was stored there. This means that if I go ahead and add to P, this thing that I have written here is 5. So if I go and I increment this plus plus, all I've done is 5 plus plus. That is the same as 5 plus 1. So for now, my interest is in letting you know that anywhere you see something like this, if you have already declared that it is a pointer, without the dereferencing sign, it's giving you the address. So if you go ahead and do P plus plus without the asterisk, what you should know is that this your one, you are adding it to the address. That address is also a number. Don't forget, it's just a hexadecimal number. It's a number expressed in base 16. And base 16, you can add 1 to it. So if you make the mistake of adding whatever you want to add, you add it to just the P, then you are adding it to the address. But if you add it to the referenced P, then you're adding it to the value that P stores. So in fact, that is why I spent all this time explaining what pointers are. For you to see when you are talking about the address and when you are talking about the wow. Hi. Hi. Can you hear me now?
What happened? What happened?
Hi. I don't know. I think the internet access. It's unfortunate. I've actually traveled, so where I am, the network is not guaranteed. And I don't have access to my Wi-Fi right now. Okay, so give me a few. Let me talk up with my but you can go ahead and ask your questions if you have any.
Yeah, some in some videos I looked at, I know you actually use hexadecimal to talk about your increment as in terms of address, how you describe it as the address of a pointer. Yeah, in some videos I saw that the way that it is being added in increments, when you're addressing your address, you're incrementing your address, they usually have a 4 bytes allocation. That is for a given address, they have like 4 bytes allocated. So if there is an increment, you're adding +4 to the address. But I don't know in the
Okay.
representation hexadecimal, I don't know how I go about that.
Okay, good. All right, so that is a point well noted, and you get to understand it when we talk about the arrays. Okay, so what happens is that when you are storing something in the computer's memory, the storage, when we are storing something in the computer's memory, the computer assigns depending on the size of what you are storing. So it assigns a space depending on the storage area, depending on the size that you are storing. So initially, when I was making the hotel analogy, I said that it depends on the number of people you are coming with. Okay, so your room, you can decide to give you a bigger room or a smaller room. And that's what is happening. So in your specific example that you have given, that you saw them do, it's just because they are working with integers. And each integer will take up 4 bytes. Even it depends on the type of computer. An integer may also take up 2 bytes. So if it is 4 bytes that you are adding on, then it means you are going to add 4 bytes. Don't worry, we'll talk about it when we discuss arrays and how they add up. Okay. So if it is a character, you're rather going to be adding 1 byte and not 4 bytes. If it is a float, you're going to be adding 4 bytes. If it is a double, you're going to be adding 8 bytes to your address. So the address, I think this has to do with arrays. Okay, so let's talk about arrays then. Ordinarily, like normal variables, normal pointers, you wouldn't necessarily add that number, okay, because the computer can choose any location in your space. But if it is an array, it's continuous. So we'll get to it and I'll explain it better. Yes, Harina.
Okay, now, so if you want to print the distance, if you want to print the variable, you distance is that and this of what the distance. This pointers, if you want to print the variable, is the, let's say, assuming you have int and asterisk p,
Okay.
equals to, let's say, the pointer sign h. So now you want to print the address of h. You print p,
Okay.
right? And if you want the value, what if you want the value that is stored in the address, which one are you printing?
Yes, so if you go ahead and print p, you are going to get an address.
Okay.
If you go ahead and print the referenced p, you are going to get a value.
Okay. I've gotten it.
Yes. So at least, please, if you don't get anything at all from the pointer discussion, remember these two things. So if you want the address, go with just the variable name. If you want the value, go with the referenced the variable name. And that is how we express them. Okay. Any further question on pointers before I jump to arrays? Yes. Come again, I can't hear you.
Okay, I say, can you hear me?
Yeah, I can hear you now.
Okay, I wanted to understand more about the errors that come with the referencing. One of which could be the, what do they call it again? The semantic fault.
Come again.
I said I wanted to know more about the error that comes with dereferencing or pointers.
Okay.
The error that is often called is it semantic fault?
Oh, really? Semantic. Is that what you said?
Hello, doctor.
Hi, Tony.
Segmentation fault.
Good afternoon.
Segmentation fault.
Segmentation default.
Oh, okay. Segmentation faults.
Segmentation
Okay.
fault, yeah.
So what I've realized is with segmentation faults, it's usually you trying to access something that is not there. So going to a memory location looking for something that is not there. So for instance, if I go looking for a character at a specific location where I've stored an integer, I'm going to get a segmentation fault. Okay, so always then you have to be paying attention to that. Or you haven't already declared something there, that storage location, there is nothing there, you are trying to access it. So segmentation fault comes in when you are trying to access something that is not accessible. Basically, when you're trying to access something that is not accessible or is not the very type that you are looking for. So it's not there.
Okay.
Yeah. So always pay attention to those things where you are using the data type you are declaring and even what you are returning, the data type you are returning and the likes. Just pay attention to those ones.
All right, thank you.
Welcome. Any other question? Okay, then let's talk about arrays.
Sorry. One more. On this
Okay.
point, I think I've seen a different ways where you are writing that p plus plus, or let me use p plus plus or asterisk p plus plus, and some are writing plus one, or there's a way some people do write it p plus one. Maybe they are trying to write an increment p plus one or p plus equals plus one, something like that. I don't know really which one is appropriate, or when is one suitable more than the other to use.
Okay. So what you should know is that something like this plus plus, it has like it's not specific or unique to pointers. It is a programming concept. Increment is a programming concept. So what we realize is that if I have a variable x and I want to increase by 1, ideally what I will do is assign this x now to the previous x plus 1. That's what is the ideal thing that you will do. Okay, so assuming that you already declared x is equal to 7, and now you want to add 1 to this 7, what you have to do is say your new x that you want is equal to the original x plus 1. This means that 7 plus 1, and that means your x now becomes 8. Now, to simplify things for us, what has been done is that instead of going to write this, we can easily write something like this is equal to 1. It's also allowed. And we all understand that if you see some expression like this, what it means is that it's x equal to x plus 1. In the same vein, another way that it has been processed is this, where it means that x is equal to x plus 1. We call this the increment symbol. So now we are allowed to use it in programming. Almost every programming language, you can use this increment symbol. But there are two ways you use the increment, which sometimes becomes confusing. If I go ahead and do this plus x, if I do plus plus x and x plus plus, even though they mean the same thing, they are actually different. How different are they? If I do x plus plus and I use it in my program, the only time that the value is going to be added, assuming x is equal to 7, okay? If I do x plus plus, this x plus plus, the 8 will only come in after whatever I'm processing is done processing. So let's see. Let me try and make this practical. Okay. So I don't know. The other way, let me try this. The other way, when you do this, okay? When you do this, assuming you are doing an operation and you have this in there, what happens is that this will first process and give you the outcome 8 before it uses the 8 for anything. Please, if you are not speaking, kindly mute yourself.
Okay.
Please, if you are not speaking, mute yourself. Oh. Okay, so let's assume that we have a condition running. And inside this condition, we have plus x. Okay, and x was 7 initially before entering this condition. Right within this condition, x will tend to become 8. Then we can use it for whatever we are using it in here. That is when you have the plus plus x. Automatically, it is added to it before the operation itself. But if inside the condition, we had this x plus plus, what happens is that This x plus plus, it depends on what you are calling it. I'll look for a special example and come and use it to explain maybe tomorrow, God willing. But what I need you to understand is that when you do plus plus x, it automatically does it before any other thing. But when it does x plus plus, it will assign a value after the operations has been done. Okay, so I think, no, pardon me to get a good example to come and explain this, okay, because it confuses a lot of people and I don't want to end up confusing somebody right now. Okay, so tomorrow's session, let me just write it somewhere so that the difference between those things is just the same thing. You know, you are adding one to it, okay, but when to add a one, is it before or after? That is what is happening here. So here it is before, you are adding before. So before you go and use this operation, you have already added your one to it, but this is after. So you would have done your operation before adding this one to it. I think if we use a while statement, while x plus plus, yes, something like this. If you do while x plus plus and x was equal to 2, what it's going to do is that it's going to check while x here will be 2, while s is 2. Okay, so if I say while x plus plus is less than 4 and say print high, if I do this, okay, the first iteration of this would be x is equal to 2 that we stated. Then it will print high. Before now, x is equal to, so x plus plus, so x is equal to 3, then it will print another high. Then x is equal to 4, then it can print high because it's less than 4. But if I did while plus plus x is less than 4, it's not going to start at 2 because this 2, when it gets here, plus plus means I've already added 1 to this. This addition is before, so I've already added 1 to this. So automatically this becomes 3 is less than 4. So it's going to print only high ones. Then the next one is not going to print. Do you get the concept? I think this should explain it. If I use x is equal to 2 and I come and say while plus plus x is less than 4, print high. As against the case where I use while x plus plus is less than 4, print high. We are interested in the first iteration, the first one that is coming. Already we know that this is 2. But before we even go to the 2, we have added 1. So we've added 1 to this x. So automatically what we are getting in the first place is this being 3. And we are checking if 3 is less than 4. So if 3 is less than 4, we'll go ahead and print x. Then we'll now do the next one. We'll come back to it and we have plus plus. So we have gotten 4. Is 4 less than 4? No. So we won't print anything. In this other case, when we enter, it is our x first that we are checking. So x is rather 2. So 2 less than 4 will be less than 4. So we'll go ahead and print I. Then because we had the plus plus, it has now added 3. So in our next iteration, that is when we will check 3 less than 4. Then we'll print high. Then in the next iteration, we will have 4 less than 4. No, so we won't print anything. So that is what makes the difference, whether you are doing plus plus before or plus plus after. Okay, it's kind of a bit confusing to people, and this is the best I can explain right now. But when we are done with today's session, I'll take my time to get examples that can help me explain it better so that tomorrow we'll look at that if time permits. Okay, but just keep in your mind, anytime you see plus plus before, it means the value is automatically added to that variable. If you see it after, it means it is in your next operation that the value will apply. Okay. Iris. So what are we interested in? We are interested in knowing what arrays are, why and when to use them, before we look at declaring and assigning values to arrays. Okay, so I keep saying this thing that the programming that we are learning, we are just building on concepts that we learn. Okay, so already in C, we've learned about the various data types, int, double, float, and things. We've learned about them. Then we've also learned that if you want to store a variable, you use what we call, if you want to store a value, we use what we call variables. If you want to store something, you create a container called variables. But what you would have noticed so far is that these variables only store single values. And you always have to declare more if you want more variables. So what are you going to do if a program has you need to assign, let's say, about 500 variables? Imagine that. Let's assume you're writing a program to sum up the score of students. Student A, student B. Let's assume there are 500 of these students and you need your program to store their scores. So you're going to declare variable student A, or let's use numbers. Student 1's score was 80, student 2's score was 90, student 3. Are you going to be able to write them up to student 500? What if there are 5,000 of them? Now that throws a challenge, because you can't sit down and assign variables throughout. Then after assigning 5,000 variables, are you sure you'll be able to even remember the variable that contains a particular number to be able to use it? So that throws a challenge to us. And what is the solution that we provide to this challenge? Instead of making a container that contains only one value, can't we create a container that can contain multiple values at the same time? So variables are containers that we have used to store values, but unfortunately they can store only a single value. This time around, we are interested in storing multiple values. So that is what brings about the concept of arrays. So it's like when we put two variables together, or two different containers together, or multiple containers together, we get what we call arrays. But what is special about arrays is that all the values have to be of the same data type. Remember that, especially when we are still dealing with C programming. Data types are very important in C programming. Otherwise, you'll keep getting segmentation errors. Data types are very, very important. And arrays help us store data of the same type, multiple data of the same type, That is what arrays help us do. So if it is integers I want to store, now I can store multiple integers, say 5, 10, 15, 20, and give it the same name, x. So over here, when we're still dealing with just variables, x could have just contained 5. And I would have to declare another one, say y is equal to 10, declare another one, z is equal to 15, and maybe a is equal to 20. I have to declare multiple variables before I can keep record of all these. But arrays make it easy for us. You just declare one. So x, then we have all of these there. So an array is just a container that contains multiple values of the same data type. Don't forget that. So the question is, what if they are not of the same data type? What happens to them? So if I have, let's say, integers and characters that I want to store together, what happens? Well, we are going to tackle that later. How or what type of container we are going to be able to put different types of variables inside. But now we are interested in the same type of data. Arrays help us store the same type of data. So I tell you that we keep building on what we are learning. We learned about a container that can store one data. Today we are learning about arrays. That happens to be a container that can store multiple data, but they have to be on the same data type. So the next thing that we will learn after some time is how to store multiple data of different data types. It shouldn't be strange. You should understand how this progress so that it becomes easy to apply. You know exactly when to use the arrays. You can use arrays when you want to store data of the same data type. There are a lot of them, and you want to put them to the same variable name. So an array is like kind of a special variable that can contain multiple values. That is all arrays are. And that's what I need you to understand. Any questions on the definition? What arrays are? Containers that store multiple data of the same data type. So if they are float, they have to be float throughout. Any questions on that? Yes. Okay. Now let's continue. Now that we know what arrays are and why we may want to use arrays, let's look at declaration of arrays, how we are going to declare an array. So already I've mentioned that we've talked about how to declare variables, how to declare functions, how to declare, today we learned about how to declare pointers. So there is something that tells a pointer, your computer, that what you have written is a pointer. There is something that tells your computer that what you have written is just an ordinary variable. There is something that tells your computer that what you have written is a function. In the same way, there is something that tells your computer that this is an array. How is that? An array is designated by the square bracket. If you bring the square bracket in front of a variable name, it becomes an array. So if ordinarily I create hi, I hope you can hear me now. This my internet.
Yeah.
What's bundle? But okay, it has come. All right, good. So let's continue. So the moment I put this square bracket in front of my variable name, all that I'm telling my computer is that this variable that I've declared called S is actually a different variable. Different in the sense that it's going to be able to contain multiple values. That is all. So to tell your computer that you are having an array, you just put your square bracket in front of it. And as we know by now, when you are declaring anything in C, you have to tell it the data type. So this is a container. What type of data is this containing? And you have all agreed that for arrays, they contain the same type of data. That means that we have to tell it beforehand. So if it is an integer, we'll go ahead and say int x this. This tells us that our array is going to contain how many, it's going to be a variable that contains integers. That is what it means, okay? Another thing that we need to know is the size of the array. Size of array. Very important. Size of array means how many values are you putting in this container. Okay, so if I say the size of my array is 4, it means that this container that I'm creating called X is going to have 4 partitions where I'm going to be storing, here we are saying integers. So I'm going to be storing 4 different integers in here. So when I'm declaring the array, I can go ahead and say int x4. This is how I declare the array. Automatically, I've told my computer that, hey, I want you to store or give me a space that can store 4 different integers. By declaring this, that is what I've told my computer, that give me a space in the memory that can store 4 integers. Then, in order for me to easily remember this, let's call that storage space X by declaring an array. That is what I have done. I've told my computer to give me enough space in the memory that can store 4 integers. And these integers, this space that you are going to give me, I'm going to call it X. So that anywhere I want to use X, I know that I'm referring to the values in there. So that is how we declare the variable. Sorry, I keep saying variable, where we declare an array. So you declare an array by telling it the data type. The data type is important because it's going to tell your computer the size that it should leave. Okay, so you should always remember that when we talk about size in computer, we are talking about something relating to bytes. So if I ask you right now, what's the RAM size of the computer you are using? Some of you may be using 4 gig RAM, others 8 gig RAM, others 2 gig RAM. And if you are not fortunate and you are using 1 gig RAM too, you may you may have a computer that is running very slow. Okay, but this is what is happening. Your computer has all this space. And if you are declaring an array, it goes in here and pick the available space. So if it is, let's say, an integer, depending on whether your computer is a 64-bit or a 32-bit machine, depending on that, you may have the integer being 4 bytes. So each integer to be stored will be 4 bytes, each integer. So if the size of your array is 4, it means that you are going to store 4 integers in the memory of your computer. So what your computer does is that it goes to look for a space for 4 different integers. Each integer is 4 bytes, and you are looking for 4 of them. So 4 times 4, that is 16 bytes. So your computer is going to look for a space worth 16 bytes for you to be able to keep the values of your array. That is what is going to happen when you declare an array. So automatically the computer will go and look for a space that can contain the size that you are giving it. If it is a character that you declared, that will be a different thing because a character will be 1 byte. If it is 1 byte and there are 4 of them, then it's just looking for a space of 4 bytes. Does that make sense? Any questions so far? Any questions so far? Okay. So now that we know, yes, anyone?
Hello.
Hi.
Okay. About characters.
Okay.
There is something that confuses me about this 34 and 60. I mean 32 and 64 bytes of character. They say when you are storing a character, you have one byte. I be 1 byte.
Okay. Byte.
Okay. I tend to get confused about the whole thing because you go to a place, they will tell you it's 4 bits. The other one they will say it's 1 byte. So I just sometimes it ends up confusing the whole thing. So you can throw more light. You're very, very nice. Thank you.
All right, sure. So what happens is that some of these values that we are quoting are actually not fixed, and it depends on your computer. Okay, but there are generals that we use. There are generals that we have assigned that now, if in the case of an exams where you have not been given the values, automatically you should know that this is this. Okay, so the common ones that we are using, say, let me start with character. Say character, we say characters, each character will take 1 byte. Okay, then integers, will say they will take 4 bytes, even though sometimes it can be 2 bytes. Then floats will also take 4 bytes. Then double will take 8 bytes. So these are the common ones we work with, okay? And you can just decide to keep this in your memory or store this in your memory, okay? Or remember this. 1 byte for character,
Okay,
4
dog.
bytes for integer, floats, yes, I don't know.
So are they, let's say for instance the character, is it 1 byte because your machine is 64-bit or
Yes, so that's why I was saying that depending on whether you are using a 64-bit or a 32-bit machine, this may be different. But for now, this is like the standard that we use. Okay, so all that you need to remember is that when you are using a character, is 1 byte. When you are using a character, is 1 byte. Just keep that in mind. When you are using an integer, is 4 bytes. When you are using a float, it's 4 bytes. When you are using a double, it's 8 bytes.
yeah,
Okay,
okay.
just keep that in mind. Yeah. I think the challenge that some of you may face is when you come across bits and bytes. These are two different things. And that's where the challenge comes in. Okay. So for now, in order not to get confused, I'll just suggest just stick to these ones and work with them. But if you want to learn more, so if you are curious enough to learn more, all you need to know is that 8 bits makes up 1 byte. This means that the point where you are saying a character takes up space of 1 byte, it actually means that the character is taking 8 bits. That is what it actually means. But what we are interested is in the bytes, not the bits. So if you find somebody talking about bits, then you should know that, oh, okay, so there is a reason to use bits. But in our case, we are looking at bytes. So for instance, 4 bytes will be 4 times 8 bits. So that's 32 bits. So 4 bytes is actually 32 bits. But let's forget about the bits, then focus on bytes because that's what we'll be using. The smallest unit of size in computer measurement is the bits. Okay, but the standard one that we like to use is bytes. So let's just go with bytes because it's not easy working in the bits. I hope that is clear.
Yeah, thank you very much. You have actually made me understand what I was confused about.
Okay, you're welcome. All right, so back to our arrays. Now we've learned about, what was it? Declaring the arrays. We want to see how do we pass the values to arrays? How do we initialize or how do we assign values to arrays? To be able to understand that, I'll need us to understand two terminologies. We have elements and we have index or indices for plural. Elements and index. As I said, an array is basically a larger container that contains multiple values. So assuming that we have declared that an array will contain integers, okay, and say we told it to contain 4 integers. Is it 4? This is 1, 2, 3, 4, 5. So let's say we declared x to be containing 5 integers. Let me put the values here. 5, 10, 15, 20, 25. When I talk about specifically each of them is called an element of the array. Each of them is an element of the array. Another name for element is member or members. So when I refer to 5 is the first member or first what? Element. If I talked about 10 is what? The second element. 15 is the third element. 20 is the fourth element. And 25 is the fifth element. So how many elements are in here? There are 5 elements or 5 members. I hope that's easy. It's a normal counting, so it's easy to understand. Just know that when you take a container that is an array that has multiple values, each is known as a member. Okay, so depending on their location. In my definition of arrays, I forgot to mention this, a very key word, continuous. Very, very key. So especially it's key because when we are looking at the storage, where the values are stored, they are always stored in a continuous order. So if I declare this array, inside my computer's memory, it's going to be stored in that same order. The order is very important. The same order in which they occur, the same order in which I initialize them, that is how my computer is going to store them. So arrays are a continuous number of number of values that are stored within a container. Okay, they have to be continuous. And each member, as I keep saying, each member will have its position. So we have the first, the second, the third, the fourth, the fifth.
Okay, Doc.
Yes. Yeah.
So does it mean that it's infinite?
No, you already declared a size. So you told
Okay, so
it
when
the
it
size
gets
that
to
you
the
want.
size, it will stop.
Exactly. That's the end. So your computer will allocate the size.
All right. Also,
Yes.
when you mentioned continuous now, and you gave an example in which you
Okay.
use 5, 15, 20, 25. In your what you are you describing when this continuous, does it take the increment by that 5, 10, 15, 25, 30? Is that what you also mean by continuous in your definition of arrays or something else? Or are you talking of a continuous in the sense that it will work with the indexes 1, 2, 3, 4, 5, as in it has to be in numerically increased? Let me understand, please.
Okay. So when I talk about continuous, I made reference to inside the storage, inside the memory of the computer. So I am in no way referring to the values. That's why I've declared another array down here. This is 5, negative 10, 7, 2, 100. These are not in any order. Okay. But once it is an array, if it is looking for a space inside the memory of your computer to go and store them, it's going to store them in the same order in which they occur, the same order in which you declared it. And the location, so if this address, let's assume this was room 106, the next one, depending on whether it is an integer, a character. So let's assume they are characters. Then we are just adding 1 byte. So if you are adding 1 byte, then this, let's assume this was 106. This become 107. The next become 108. The next become 109. In that order. So the continuous is reference to the storage site where it's going to be stored. It's not going to now put, let's say this, let's assume there were characters that I put here and say A, Z, X, B, Y. If these were them, it's not now going to put A here and come and say, okay, let me rather put B here before I bring X, Y, Z. No. It's going to put them in that same order. We have A, Z, X, B, Y. Then it's not also going to put A here, put Z here, put Y here, put X here. If you would understand the continuous better, if you remember what I said about ordinary variables inside the memory of the computer. If you declare X may be put here. Maybe I didn't say it in today's session, but I said it last 2 days. X may be stored in this part of your computer. If you go and declare Y may be stored here. Say Z may be stored here. So the computer randomly assigns the storage space, the location. The computer randomly does that. But the moment you assign an array, all the values of the array will be put in that same order in the computer. So randomly, the computer will choose a specific location to store. But as soon as it spots this location, the rest will follow in that order. It's going to be a continuous one. So that is what I refer to as by continuous. When I say the array is continuous, it has nothing to do with the elements of the array. Say here I use 5, 10, 15. No, that has nothing to do with it being continuous. In your storage, it's not going to randomly assign the individual members their own sites. That means that it translates into our address. So if I know the address of the very first one, I can get the address of the second one because they are stored continuously. If I know the address of the last one, I can get the address of the previous one because they are stored continuously.
So
Storage
by
location
continuous,
in the computer.
so by continuous, you mean an orderly arrangement
In the memory of your computer, yes.
All right. Thank you very much.
You're welcome. Okay, so now we've talked about elements. Let's look at index. So index is not so different, except that when we start counting, we count from 0. So this first one that we see here, the very first member of the array happens to be index 0. The second one then becomes index 1. This becomes index 2. This becomes index 3. And this becomes index 4. Pay attention to that. Mostly, when we are working with arrays, we'll be working with the index rather, not the elements or the members. So you need to always pay attention to that. Your computer understands the index, not the element or the members. When you are speaking or you are writing about it, you tend to use the elements and the members because it's easy for you, the humans. Oh, the first member of this array is 5. But the computer doesn't know what member is. You say it so that you feel comfortable saying member, elements. It's easy. The computer uses index or indices. So if you go and say the first index of the array is actually not this, but rather this, because this index is index 0. So always keep that in mind. If you declare an array of size 10, what it means is that you have 0 to 9 indices or indices. If you declare an array of size 10, you have 0 to 9 indices. Never forget that, because 0 is counted as the initial one. So if I go ahead and declare an array of size 3, which are characters, I can assign the values by saying this is equal to this curly bracket is what we use to represent the values or the container for the arrays. Okay, so say I have Z K W. So this is telling us, like, this is how we declare and initialize. Okay, I've declared it here. So this is how we initialize the value, or we pass values, or we assign values to the array X. if I want the indices or the index of the members, this is index 0, this is index 1, and this is index 2. To access the members of an array, we can use the index to access them. So if I go ahead and I write x of 2, if I do this, mind you, this is not when I am declaring. When you do this during your declaration process, you are just telling it the size of your array. Please remember this. When you do this during your declaration, what you are doing is size of array. Okay? But when you are using it and you do this, what you are doing is index of array. So if I say x index 2, I am looking for the second index of this array, which happens to be this, index 2 of this array, which happens to be this. So this will give me the value w. Let me take that again. To declare an array, we go ahead and tell it. So if it is integer, we say int, then let's call our array school. Then we want to pass the number of schools, say 7 schools. So we have an array that contains 7 integers. This thing that we have done here, this 7 is representing size of the array. Size of the array. But if we come down after initializing it, so let's go ahead and initialize this array. Say it is equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So let's say that is the array that we have created.
Okay, no.
Yeah.
So you are not bringing the 7 into the block brackets again.
Oh, here.
Okay,
Is that what you're saying? Is that what you're saying? You have already declared the size, so you don't necessarily need it again.
Okay, you don't have to.
You don't necessarily need it because you already declared the size. So you can work without declaring the size. I could have just declared it if, okay, let me say this. In declaring the array, you only give it the size when you are not automatically initializing it. What do I mean by automatically? So in my declaration, we all know, for instance, if I want to declare a variable from our previous knowledge, if I want to declare a variable, I could do this. Or I could do declaration and assignment the same process. Okay? So these two are valid. I could have done this and y, then go ahead on another line and say y is equal to 10. I could have done this, and it's the same thing as this. Okay, so in declaring arrays to it's similar. We can say int school, then pass the size. When we do this, it means we are not telling it the exact members, but we are telling it that, oh, create a space on the computer's memory to accommodate 7 integers. If you go ahead without passing the size here and you just say int school here and ending, it's going to give you a problem because you are saying that it should create an array, but what size? What size will it give you? Okay, so to tell it to create an array, if you are not telling it the exact members of the array, then you need to explicitly say how many values it should create the size for. However, if you don't want to create the value of a particular size, then what you need to do is that you need to tell it that, okay, so I don't know the size I want you to keep, but here are the members. So you count and tell yourself the size. Okay, so if I do this, then the computer will automatically find 1, 2, 3, 4, 5, 6. So there are 6 members in this array. So in my memory, I'm going to keep 6 spaces for space, 6 integers. That is what the computer is going to do. So this is one way to declare an array. The other way is just to say school, pass the number there, then end. Then you can go ahead and initialize it with this. 1, 2, 3, 4, 5, 6. Yes, go ahead.
I think what you're talking about in this case is the 2 ways of declaration. That is implicit and explicit declaration of arrays.
Yeah.
If I'm sure, if I'm trying, am I getting that?
Yes, that is it. So there are 2 different ways that we can declare an array, and that's what I've tried explaining right now. Okay, so let me tell you when you can use what. This, you use this form of declaration when you know the exact members of your array. Okay, when you know the exact members of your array. So the array has its values already stated. So during compilation, the values are already available. But there are some that the values will only be generated during runtime when your program is running. Assuming that this array that you are creating, you are actually waiting for the user to pass the values of the array. That means it is when your program is running that you are going to get the value. So if you don't know the values, then you have to explicitly give it the size. What is the size? Tell it the size. So if I'm going to create an array that I'm going to be taking the values from someone else, then I need to tell my computer that, hey, this array that I'm going to create should contain 70 items or elements. So that the computer will automatically create that space for 70, then now await the values that the person will be bringing in. But if you don't do that, your computer doesn't know the size to allocate for your array. Okay, so very important. You either declare an array. Yes, go ahead.
Okay, I think at this point now, I don't know if this is the right time to ask this. Are we going to include are we going to, when you're talking about runtime and when not in runtime when you're already started and when you have not yet started. I think in the case where you have already started, is it the time they use things like null or terminating zero? I don't know. Those terms usually mess with someone's head. I don't know if it's when to include that.
Okay. All right. So we'll discuss strings tomorrow. Just note that this thing that you see there, end with 0, is just in strings. The string, as we know, is just an array of characters. Okay, because we've already learned about characters. When you go to other programming language, we have strings themselves, so we don't worry about it. In C, unfortunately, we don't have strings, so we use them as characters, arrays of characters when you put them together. So for the computer to know that you have ended a string, that is when you bring that thing there. And we are not talking about strings right now. In your normal array, you declare the end of your array by writing your size. I know your size. If I declare my array to be size 7 and I end up adding only 6, my computer has automatically created and given that space for the 7th thing. Okay, so it could be that any data at all could be stored in there. It could be some gibberish that has been stored in there because I didn't declare anything for it. That is what you should know. So when we start talking about strings, then we'll look at that. But for now, just know that for your array, it is what you pass to it. If you give room, the computer will automatically save that storage space for you or leave that space for you, waiting for all the numbers or all the values that you are going to assign. If you are not able to accommodate the rest, that space is still there. But unfortunately, you cannot tell what was there because there could be the space that was allocated for you could have been containing something else already. So if you had provided a value, that would have replaced it. But since you haven't provided a value, it could contain anything at all. So in C, you should be mindful of your declarations, especially the size. You should always tell C how much data you want to fill it and make sure you fill it. Because if you don't fill it, sometimes it will not throw an error. C does not, like the compiler or C as a language in it, we don't check for the boundaries, especially when you are dealing with arrays. That's why when you are working with strings, automatically we add that boundary to it so that it knows that the string has ended. Otherwise, when you print out your string, it would have added some gibberish that it has in its memory already to you. Because it depends on where the computer stored it. So assuming I said your computer, yesterday I used this example. The computer's memory, let's assume this is the memory. And already, so let me try and make a grade out of it so that makes more sense. So let's assume that these grades that we are creating are the specific locations within the memory of your computer where the data is being stored for processing. Okay, so if previously your computer had a variable called x stored here, and maybe it had y stored here, it had, let's say, z stored here, z was equal to, let's say, 10. Okay, and say a is equal to, let's say, the character h stored here. Okay, let me assign another one and say b is equal to character e. Let's assume this is a section of your computer's memory. Remember always that the computer will randomly assign a location for what you give it. But if it is an array, even if it is not an array, the computer is always looking for the size that you want. Can it fit here? Okay. So if, let's assume that each of these, okay, because I'm come to use integers, let me just convert these to integers. Say this was 1, this was 0. And let's assume that each of these grades is just 4 bytes, meaning each of these grades can store a single integer. That is all that it means. If they are all 4 bytes, it can store a single integer. This means that as soon as you go ahead and let's declare a new variable called AB and assign it to 25. Your computer will randomly put it somewhere that it can fit the 4 bytes because this is 4 bytes, or it needs 4 bytes to store this value. So it will automatically look at it and pick one. So now that we know each of them is 4 bytes, it means each of these storage areas can pick this value. For that matter, it will randomly assign. Let's assume it assigns it to this. So AB is equal to 25. Assigned here. Now, if you want to assign this or declare this, array. We know that this array has 6 members, 6 integers. For that matter, your computer is looking for 6 times 4 bytes space. Okay, it's looking for 6 times 4 bytes space. So it will now search 1, 2, 3, 4. It hasn't gotten space for this. 1, 2, 3, 4. No space because this one is there. 1, 2, no space. 1, 2, 3, 4. So per what we have currently, we don't have space to store our array that is coming. So let me just make room for that. Assume we didn't have anything here. Okay, so let's say that this array that we created was this variable was rather stored here, it's equal to 25. Now we have 1, 2, 3, 4, 5, 6. So your computer can randomly decide to pass your values here. First one, second, third, fourth, fifth, sixth. Okay? Since counting from this side, 1, 2, 3, 4, 5, 6 can also give us, it can decide to put them here. 1, 2, 3, 4, 5, 6. All the computer cares about is that there should be enough room to contain the space that you have. Now, let me go ahead and delete these ones that I've added here, then do an example to illustrate why I came to draw this. Okay, so let's assume that even before we declared this array that has 6 elements or members, there was another variable here or another value stored here, say 81. If we go ahead and declare this, we'll have it stored somewhere here because that's where the space was allowed it to store. So this has the address, the array has its address or the location. Each of these spaces has their unique addresses, okay? So we know the members that we are looking for. If you go ahead and make a mistake and call for the index that is not available, index 6, because this is index 0, index 1, index 2, index 3, index 4, index 5, and index 6. I told you earlier that in array, they are continuous and the computer stores them continuously. So once you have called for index 7, your computer will automatically look after, index 6, rather, I'm talking about index 6. Your computer will automatically look for the value after index 5. And if there is a value there, it will print it out for you, 81. Meanwhile, you didn't declare 81 as part of your array. That's a problem with C, and that is why you need to be explicit enough to tell it the size that you want it to take. C doesn't check the boundaries. It doesn't check if your array that you declared was only 6 members. For that matter, it has up to index 5. C doesn't check that. If you are working with other programming languages, they will throw an error and tell you that you do not have more than this in your array, but C doesn't do that. So it will just go into its memory. The next thing that was there or that location that you are calling it will count and push whatever is there for you. If you are fortunate enough and there was nothing stored there, then you are not going to get any value returned to you because there was nothing stored there. But assuming there was something else stored there, it's going to print that thing that was stored there out. If you are not lucky and it was a pointer that was stored there, it's going to print out the pointer to you. Yes, go ahead and answer your question.
Okay, thanks for this explanation. Now, there are cases, I don't know if this is proper, but there are cases where someone might decide in the array, he gives more space. Let's say you're actually bringing out values in your array that is of let's say you want only 5, but you're now in your size you're declaring 7. You're declaring more than the actual number.
Okay.
Is that a wrong syntax or is it problematic?
Is it the example that I'm giving here, or you are giving an example? Let me understand that.
It's somewhat similar to what you are just explaining now.
Yes.
But if it's proper or if it's the wrong syntax, or if it's an error, it will give you an error. I want to know what applies to that.
All right. So I've gotten your point. Let me try and illustrate that. Okay. So now let's call an array bus. Then this array, we've declared that it should take, let me go down small, use just 3. It should take 3 elements. We've declared that this array should take 3 elements. As soon as you declare this, your computer makes room. So the memory of the computer is just going to make room for 3 words. If you are using integers, then 3 times 4 bytes, so 12 bytes. Your computer is going to make room for 12 bytes. Okay, so let's assume each of them is the 4 bytes. Each of the grids I'm going to draw here is 4 bytes. Okay, if you have something like this, all your computer care about is that now you want space for 3. So you can allocate 1, 2, 3. So if you go ahead and initialize this, your array, to just 1, 2. Once you have initialized this, all you have done is you've passed values here and here. You've not passed a value to this. So the computer would automatically have found a space for it, but you haven't yet assigned a value to it. So you are allowed to assign a value to it, and it's going to work. It may not throw any error to you because it has already created that space, and you can decide later on to pass a value to this specific one. So this is index 0, index 1, and index 2. So you can decide that, okay, for index 2, I want to assign index 2 to the number 4. Then that space is waiting for you, so the computer will go and put it in there. If you end up not using that space, it becomes free and the computer has access to use it. So if another program or a function somewhere or a variable somewhere automatically needs space and that space is available, you can then reassign it to it. But so far as you have declared that you needed 3 space, it will give you that space. Even if you have not filled it, it will be there for you. It will be kept for you, and at any point in time, you can assign a value to it until the space is given out and something else uses it. I hope that answers your question. Any other question? Any other question? So if you make them, yes, go ahead.
Okay. I don't know if it's now you're going to talk about increments. Are you getting to that as well?
What do you mean by increments? Yes. Can you hear me?
I think you already talked about that now.
Yeah, so that's why I want to know what specifically he needs to know. Because as I'm saying, today what we are interested in right now is for you to understand the concept. Okay, because right now we've already passed 2 hours. We just need to understand the concept. Tomorrow then we'll take the practical ones and work with them. Okay, how to. So tomorrow's session we'll be using the compiler, then showing practically how these ones are done. Today is just for you to understand. And I don't want us to drag back tomorrow whereby we start doing something and someone is now asking, oh, why did we declare it this way? What was the meaning of this? Okay, that is why we are taking our time. In fact, I keep saying that we did this lesson last 2 days. Okay, unfortunately, because we couldn't record it, that is why we are having a repeat, so that those who missed last 2 days on will get to know it before tomorrow's session. So tomorrow, that is when we are going to deal with the practicals. Now I need you to understand them. So if you understand, that is fine. If you don't understand, this is the best time to be asking questions, so that when we get into the practical, you wouldn't have all those questions hanging. Yes, questions, because we are coming to the end, actually. To access the value of any array, you just need the index. Remember, the index always starts from 0. Don't forget that. That is the biggest challenge people face when working with arrays. Index always starts with 0. So if we say index 2, then you have to start counting 0, 1, 2. Don't make the mistake of counting 1, 2, 3. Index always starts with 0. And when you are working with strings, which we are going to look at tomorrow, strings are just arrays of characters. So you are definitely going to be dealing with this. Your index always starts with 0. Index 0, index 1, you should just understand it. So to access a value inside a variable, this is what you do. Pass 2 to it. That means you are accessing the value at index 2. So 0, 1, 2. If you pass 3 to it, index 3, 0, 1, 2, 3. Hi, Ima, you saying something? Yeah.
Good afternoon. I think
Afternoon.
what Edo is trying to ask is if there is any increment or decrement in arrays once you have declared it or something like that. Not the way there is an increment in characters and integers and the rest.
Okay.
So I think that's where
So
it started at.
one thing we need to know about arrays is that in C especially, working with arrays is very difficult. Very, very difficult. In that changing arrays or adding on, expanding it isn't that straightforward. Very difficult. It's unlike other programming languages. You can't just easily manipulate values in arrays in C. Okay, so that is not an easy thing to do. However, what we will need to know is the addresses of the various members of the arrays. Then we can manipulate the addresses of the various members. Then if you check correctly, I think inside the concepts that were given to read on Monday, you would have seen a concept called data structures. Data structures. And data structures are like how data is organized in various forms so that it helps us assess or to be able to manipulate it anytime we want. Okay. So arrays are just one type of data structures that we are looking at. We'll be looking at different types of data structures, and each of them has its own advantages and disadvantages. One disadvantage with arrays is that modifying an array is a bit difficult. Okay, so let's just keep that in mind. When we go to other programming languages, we may find it easy to just add on to our array and things. But for C, because it is dealing directly with allocating a size, we need to be careful when you declare it, unless if you work with the, how is it called? The size, like the address of your location. So I think I have to talk, the last thing I need to talk about is the address of the arrays.
Sorry. Let me ask something.
Okay.
Yeah, you. There's a way you actually described your arrays and curly braces. You know, they are enclosed in curly braces. Your elements or members
Okay.
are in
Okay.
curly braces, right? I don't know if this is peculiar to the pointers or the arrays, where in some cases you might be seeing instead of block brackets, you're actually seeing the curve brackets. You know, I don't know whether it's pointer to arrays or something. You're actually seeing the curve bracket P, then in this curve bracket, or some cases you're seeing curly bracket before you're making an assignment. All right, or sometimes you're seeing in the assignment block, it is taking a block shape rather than curly brace shape. I don't know if those members of the one that are in block and the one that are in curly brace have the same way of performing, you know, because you actually mentioned it that these arrays come in curly braces. So if we try to see it in a block code or block shape enclosed in a block, how do we treat them? Are they different, or is there anything that we should need to take note of? That's what I want to be sure of.
All right, don't mute yourself. I'm trying to
Trying
understand
to
what you asked.
understand.
Okay.
Okay.
Do you mean something like this? Let's say 1, 2, 3, something like this. Is that what you are
Yes,
talking about?
yes. Some are curly, some are block. Are they the same thing, or they are different? When even also the as the what you're assigning it to, like let's say your
Sorry.
P or your differencing P, and you're writing it in curly or writing it in block or bracket exactly. How do we look at it? Are they going to be treated alike, or is there any difference between this kind of arrangement, this kind of enclosing the brackets? Are they treated equally, or they have some significant differences? That's what I want to know.
If it comes to assigning values to an array, I'm yet
Yes.
to come across something like this, and I'm yet to come across something like this. So what I know is that to assign values to arrays, this is what we use. Values to arrays. Okay. And in fact, this is in almost every programming language. This is what we use to pass values to an array. Every programming language. C unfortunately does not have something, but in other programming languages too, which I think it's similar in a way how we use C. We call these things objects. Okay, so objects are usually declared or assigned values in this way with a curly brackets. I am yet to see something like this as the values, but as I said earlier, this is for you to tell us either the size, the square bracket just tells you that it's an array. Okay, so if I had just as I had it in front of this, then it's telling me that this is an array. For that matter, whatever I assign to it can be this way. Okay, then the values you pass in here are just values that you are either saying the size or the index. So if I should have something in there and say 2, then it means that I'm looking for the index, this index of 2 of this array X. For this brackets, if we are not working with functions where we have them, the arguments being passed in here, I don't know why you'll be using this for assigning values. However, when we are doing some form of arithmetic operations, where tomorrow we'll be looking at it, where I think that's where your confusion is coming from. Something like this, or having this and having your p+1, something like this. All of these, tomorrow we'll look at them practically. But to assign a value to an array, what I know of is this. Unless if there is something that I don't know that any of you may want to throw more light on. But this is what I know for assigning values to an array. Yeah.
Okay. I'll look for more insights on this and see if I
All right,
maybe I'll
sure.
share it. Thank you.
Okay, I'll appreciate that. You're welcome. Guys, any final questions? Because I think the last bundle I bought is run out.
Okay,
I've
now,
traveled a lot. Yes, Harina.
so in this array, the values inside, do they have address? And if they have, how do you get
Yes.
access to the
Sorry,
address?
that's what I wanted to talk about. Okay, address of arrays. Let me end with that one. With arrays, all that your computer is interested in is that the address for the very first one. Because when you get the address for the first member of the array or index 0, you can automatically calculate the address for the others. So if you have an array of integers containing 1, 2, 3, okay, what is going to happen? Because they are integers, when your computer creates space for them, it knows that, let's say these were the space, this contains the first one, second, third. Each of these is 4 bytes. Okay, the storage space, each of these is 4 bytes. So all you need to know is the address for the first one, that's in the 0 address. Okay, so if you declare an array and you go to check the address using the address of sign, okay, if you check the address of this array, it's going to rather give you the address of 0, that I mean in the 0, so the address of the first member. Once you get the address of the first member, if you want the address of the second member, just add 4 bytes to it. If you want the address of this, just add another 4 bytes. If they were characters, then we know that we are dealing with 1 byte. Yes.
So this is where you were saying is continuous.
Exactly.
Right.
Exactly.
Oh,
So you just
okay.
need the address of the very first one. Once you have the address of the very first one, so if you create a pointer to an array, the pointer just points you to the first item of the array, or the first member, or the first element of the array. Then you, knowing very well the data type, if it is double, then we are dealing with 8 bytes. Knowing very well the data type, you know the size. So you can add on the size to get the specific one that you are looking for. I hope that is clear. So for arrays, the address is just the first one. Yes. Go ahead.
I don't know is I don't know if this pertains to what we are dealing with arrays and pointers or strings, but I sometimes I hear this term pass PARSE. I don't really know how they imply it, the implications of the word pass, how it's being used. Maybe it could even be applicable in these arrays and pointers. The word
What is your
passing,
understanding of pass?
I don't know. I don't know. I just hear the thing and I'm like, what? And I also hear another one, buffer. But I don't. I'm more concerned now of pass. What do they mean when they are passing values into it? I don't get it.
Because I think that this is more of an English word than any other thing right now. Well, it doesn't have any special connotation in programming per se. So, act of passing a string or a text resolve into its component parts and describe their syntactic rules. So, the English word pass is resolved into its component parts. Okay, so I think it has to do more with English than anything. So if the person is using the word passing an array from the English definition, it's like breaking the array into its members. So I don't think it's personally I don't know of like I also hear it, okay, but it's just the English word that I know. Doesn't have any special connotation in programming. Unlike something like buffer. Buffer is something different. That one there is like some sort of a storage area that they keep things. Okay, so that is a bit different. Pass is not. If what I remember, if cast that one we'll talk about them later. But for now, if any other person who has an opinion on it, you can just unmute and share. I don't know what else I can say about pass.
Hello, good afternoon, sir.
Good afternoon.
Mine is a question, anyways.
Okay.
Sorry, I didn't join on time. Please, can you basically tell me what points are like? In general, what points are refers to? Just that particular concept.
Okay. So I said a pointer is just a variable or a container that contains an address. Okay. So it just points you in the direction of something. It's just like me giving you a sheet of paper that contains someone's address that you can follow and go and find the person. That is all. It's just a variable. That variable, what it contains is just an address. And you know that if I've given you an address leads to something. So if I give you a pointer, the pointer contains an address that you can use to locate something. That's all. Tomorrow we will be doing practicals of
Thank you.
these. Okay. You're welcome. Please, please, please. I would like to take your questions, but unfortunately, I've drained 3 times bundle that I've done already because I didn't get the right bundle I needed, and I don't have my router here.
Time,
So I
please.
would want tomorrow's session should be tomorrow is a normal PLD, so it will be 1 p.m. GMT. I'm in Ghana, so I put the time in GMT. So depending on the country that you are in, find the time. But we'll share the link around when it's time. And obviously, we are going to be having it in the Telegram group, so you may get notification when we start the session. But 1 p.m. God willing, tomorrow we'll have our session. All right, so we'll end the session here. I'll try and upload the video as soon as I can so that those of you who want to revise before tomorrow's session, you can as well go through it. If you have any questions, we are in the group together. You can always ask your questions. And remember, I'm also a student, just like you, or I'm also learning. I'm new to C programming the same way you're all new to C programming that we are learning. Okay, I happen to have previous programming knowledge, so that is what I apply to be able to explain some of these concepts. So let's not see it as I'm the only one who is supposed to be answering questions that come. I expect all of us to be helping ourselves. So if any questions come, you have knowledge on it
Has he gone? Has he
Maybe
gone?
maybe his data has finished.
Yeah.
So we'll just call it off. Well, we'll meet tomorrow again.
Elon Musk is here. Oh. Humphrey, Humphrey, good day. Welcome. Elon Musk is here. Oh. Right.
Are you sure that's Humphrey?
No, Humphrey. Oh. Mhm.
I know they see him picture.
You know this in there on the low.
Well, men they here. Which one are they find now, men?
Ladies day too. Ladies, sharp ladies here.
Like Anita, Abi.
Anita day now. I don't know. She dey in and out. She's always in and out.
Hmm. So today we don't finish now. Tomorrow na practical. Na that one na they sweet me.
You don't go buy your practical instruments, your drawing board, what he said.
When doctor be make mention say tomorrow na practical been come out. I can say
Eh,
na definition of area I won't conde here.
yeah.
Zuri they deal with me first.
I
Oh,
pack
yeah,
out.
no.
All right, later. Closure. Closure.
Hi.
Hi. So I'm just joined. We don't shut down.
Thank you for coming.